is apa? Which is a lot of mistake will be after the load estimations. Okay, if you do something's wrong with the load estimations or load estimations here. This chapter also will be included in the test. Okay, your test will be tested from chapter 1 until chapter 3. Okay. Uh, Please take note, okay, your test will be on 19 May, if I'm not mistaken, 19 May, okay, at night. If have any subject that clash with this date, okay, please ask that lecturer to change the date, because we already fixed the dates, right? We already set the date earlier, right? Okay, first of all, you need to understand what is actions and what is load, where the loads come from. Okay, this is very main important thing to consider during the design process. Okay, which is load also is defined as an external load. Okay, it also defined as an external load here. Jangan saya punya pen loading. Okay, this is what I mean, which is external force. The external force is come from, remember, we have a load of permanent load, we have variables loads, right? So all these loads will be resisted, will be carried by the structure. So we have to design to provide reasonable performance in terms of safety, serviceability, what else? Dia punya stability, right? Okay, during it working life here. Okay, so the load is influenced by many factors. Okay, first of all, it's influenced due to its functions. So different functions, okay, will give a different load. The permanent loads, the variables load for the classroom is not same for housings or for the multi-purpose hall. Okay, so that's why we have to know what's the functions of the area, what's the purpose for that space. So that's why in the architect's drawing, all the information should be proper. So that's why I'm very stressed on in selection of proper architect's drawing. You can see in the architect's drawing, there are symbols, there are labels or informations, what the purpose, what the space function for that area, right? Because that information will give us to determine what's the load that apply on that area. And then size and shapes also. Normally architects will give their purpose, their proposals on the size, on the shapes. Okay, from the size, from the cross sections of the beam, we will use it in order to calculate its surface, right? Also the brick wall, we have to know the elevations of the building, because we want to know what is the height of that brick wall. The height of that brick wall will be multiplied with the weight of bricks. So that's why we have to know all the size, all the shapes. And also location, situations, or what the environment impact on that structure. Is it low humidity or exposed to the seawater? Kan? So this is all the things that will influence the load of the buildings. Okay, so at the same time, in order to optimize the value, okay, we have also to concern about the budget, about the cost. Okay, beside of performance lah, beside of the safety and so on. The cost also will be our considerations. Okay, if you provide more enforcement, which is over enforced, might be you think that will be for the safety, right? You provide a lot of reinforcements, big size of main bar here, but how about the cost? That means you have to design wisely, just nice, sufficient, which is equivalent to the required load that will be carried out. Okay, so in load estimations, there are many types of actions, okay, according to the structure part. Okay, let's say for the slab here, okay, we have a permanent actions, which is GK, and then also we have to consider the variable action, which is QK here. So if I sketch the slabs here, which is this slab is supported by the beams. Okay, so this is the slabs. So this is the beam here. Okay, so the types of actions for the slab here, of course, it owns self weight. Okay, of course, it owns self weight. What the slabs made of? Is it by concrete or by steel or timber? Each of the material have its own unit weight. Okay, let's say for concrete, the unit weight of concrete is 25. Okay, which is kilo Newton per meter of tray here. Okay, so we have to consider its safe weight, and then finishes and services. Okay, remember on top of slab there are finishes, which is it can be ceramic tiles. Okay, what else? It can be vinyls, floorings, right? Might be just a cement render. So all of these fix, okay, all of these give a load also to the slab, okay, per area. So that's why we have to consider about the finishes, which is all of these finishes, and also services. Might be this slab also have a piping inside of it, and then we also consider about the shieldings. So normally it will be hangings below the slabs here. So this is all the examples of GK. Example for the permanence load here. And then variables, which is variable, it depends what the function of that floor. Might be for kitchen, the QK is equal to 1.0. For classroom, the QK is 1.5. So that's why you have to refer in a euro codes, in the tables. Okay, depends according to the functions of the floor. Okay, how about beam here? Look at of this beam. Okay, so this beam will support the load from the slabs, right? So that's why there will be a permanent load come from the distributions from slabs. Okay, and also from the roof. Kalau dekat apa ni? Dekat top levels lah. Okay, so all the loads. Okay, try to change color. Semua tukar pula ya. Tak berjaya. Okay. Okay, so distribution from the slab. So that means we remember we have a type of one-way slab, we have a two-way slabs, right? So example for a one-way slab, it divide by two. Okay, so half of the loads from the slab will transfer to this beam, and another half will transfer to this beam. So that means this beam will carry the load from slabs, and also it have own safe weight. Dia pun ada safe weight. Depends on the materials of the concrete beams, and then the beams also will support the brick wall. So the brick wall will be applied its loads to the beam. So if you look at here, the beams will support the load from slabs, will support its own self weight, and also brick wall if the beams have a brick wall. Okay, sometimes the brick wall kan, especially at the for the roof beam. Okay, for the roof beam. Okay, for the roof beam here. Tak ada pun brick wall kat sini. Ni all this is a beam here. Okay, there's no brick wall for the roof beam, but for the first floor beams, there's a brick wall. For the ground floor beams, there's a brick wall, okay, to be considered. And then variable actions. Okay, so this is actually not included in the beam, but we've already calculated in the slabs here. Okay, there's no function for the beams, right? The functions normally applied on the slabs, applied for the floor. Okay, the usage of the housings, which is normally on the slabs. Okay, so that's why most of beam we not consider about its QK. Same goes for the columns. Okay, for the column also, which is QK, who gonna sit or standings or live on the columns, right? Okay, so QK is 0. How about its GK here for the columns? Okay, if you look at here, below the beams that supports all the structure here is a column here. Okay, is a column. So that means the columns will support the load from the beams. So the beams will transfer its load to the column. So that means column will consider the load from the beam and also its self weight. All right, and also for the foundation here. Okay, below of it is a foundations. Bila I mengajar, you all pun boleh buat sketching kan, nak bagi faham, nak bagi you boleh imagine sebab tak bagi sight, tak nampak, so you need some efforts, okay, to understand here. Okay, so foundations, dia punya GK is of course is from the column here, okay, and also its self weight. So for the QK of foundations, normally we not consider. Okay, most of the QK we consider in the slabs, right? So this is what the unit for each of the structural part here. If you look at for the slabs, so the slabs will transfer all the load per area here. So that's why the unit is kilonewton per meter square. Okay, for the beam, okay, in line, okay, kalau slab per area, kan, all over the slab here. So that's why kilonewton per meter square. For the beam, so this is the beam. Okay, this is the beams, which is in line along the beam length here. So that's why kilonewton per meter. And then kalau buat sketch 2D lah kan, 3D. So this is the line for the beam here all along of this. This is a area for the slab, while this is for the columns here. That's why there will be a point load. Okay, for the beams transferred to the columns, and also for the columns transferred to the foundations. Alright, so in this slide you can see how the load distribute. Is it per area, per lines, or per point load here? So this is examples all over the area of the slab, and then this is examples for the brick wall. If have a brick wall along this side here, so the load will be per line here. per meter, and then this also per meter, kilonewton per meter for the beams. Okay, and then point load here might be, there will be a secondary beams, right? Like crossings that support by by the beams, or might be there's a columns. Okay, there's a column within the slabs area. Okay, so all of columns and foundations here is considered as a applied point load. If you look at here, once we do the estimations, once we do the calculation for the load distribution, we distribute it from top to bottoms. Kita calculate dulu dari slab, pergi ke beams, pergi column, pergi foundation. It's from top to bottoms for the load estimations. But once we want to construct, we have to construct from bottoms to tops. Okay, so that is two different method kan. Kalau nak construct sama macam estimation ni from top to bottom, macam mana? So we have to make a foundation first. Okay, then we move to other levels. So that's why this is two-way directions between designs and also constructions. Okay, we go for permanent actions of slab here, which is GK. So first, we have to consider about its self-weight of slab. How to calculate is by consider its thickness. So slab have a thickness, okay? Because we want it per area, so it doesn't matter what's the area of that slab. But what we concern here about its thickness. Okay, so let's say 100 mm. Okay, so you have to multiply with the unit weight of concrete, which is 25. So 0.1, make it in a meter. So multiply with is 25 here. So you will get kilonewton per meter power of 2. So commonly the slab thickness is 100 mm, and the maximum slab span here, okay, which is short divided by long span is a 36 H, which is, this is the ratio. Okay, actually this is just a guideline. So normally we go the minimum for 100 mm. Nak less thickness pun tak boleh sebab dalam tu ada reinforcement. We also have to provide the concrete cover. We also have to provide this space for the reinforcements, right? So that's why this is the suggested minimum slab thickness 100 mm, and also this is the suggested maximum slab span, okay, which is short divided by long span. Let's say this is the LX, which is the short span. This is the LY of the long spans. Okay, is equal to 36 H here. Okay, it should be within this range. Okay, so then we also consider about the finishes of the slab. Is it made of ceramic or just a cement render? Or any other flooring systems. Okay, so this is examples. If using a ceramics, okay, these tables is come from the manufacturer. Okay, come from manufacturer. We have to consider its weight, right? So this is the weight of let's say for this size. Okay, make it to kilonewtons and then divide by its area. So you will get the load, okay, for the ceramic tiles, and then ceramic also have it a cement render, right, in order to bond, to make a bonding between ceramic tiles and also slab here. Okay, ada mortar kat sini, right? So what the thickness of that cement render? So this is the density or unit weights of the cement render multiplied by is to make it, to convert to kilonewtons, and then this is the thickness of the cement render. So all together That's give a load to the slab, which is 0.22 plus 0.56, which is, this is examples of total finishing load from the finishers. Okay, but normally in a test or in an exam, we just give you a value for the finishers. So let's say we just mentioned the finishers, services, shilling is equal to 3. So you just use directly that's value. But if not given, so you have to calculate by yourself, okay, all the finishes. And then also for the shillings here, there's another one here. If it mentioned there's a shillings which is supported by that slab. If not, you just ignore about the shillings load. Okay, so the shilling we normally in range 0.3 to 0.5 already in kilonewton over meter power of 2 here. So nak guna 0.3, 0.4, 0.5 is up to you. That is why engineers should make a lot of decisions. Okay, you kena buat decisions. Masa belajar ni kita just bagi je value. Mungkin ada certain value yang you kena cari. Ada certain value yang you it's standardized to all the students. Why we make it like that? Because in terms of the answer scheme, kalau semua bebas nak cari size, nak cari value, so how about the answer scheme? Berapa banyak kita nak sediakan answer scheme? So that's why some of the value we have to standardize. We have to fix one value to all the students. But in reality, once you be an engineer, okay, all of the loads, all of the estimation you have to make, okay, according to your experience, decisions, that is the differences, okay, once you go for the real designs. Okay, so that's why nanti bila you buat estimation, you can decide between this range. Okay, so then how about QK here, which is remember QK is based on the functions of that slabs, right? Is it bedroom? So you have to use 1.5 for the QK. Okay, there's a 2 unit here. Remember, this is per area. Okay, we go for this area. And this if you consider as a point load. Okay, it depends, okay, what's the types of that space too. So that's why this table is a very important, that you need to know where's the location for these tables. Open up your EC1, okay, please find out this table. This is a very important things, okay, that you need to know in order to estimate the variable actions of this lab. Okay, so this is also based on the category here. Some of the tables is relate to other tables. Okay, let's say for this one, A1. A1 actually is come from this A. Actually, a category here have another tables. Okay, so from tables to tables you have to refer. If I give an example here, okay, can you see I change this to the other slide? Nampak tak? Nampak Okay, so this is a Euro code that you need to refer. So I believe some of the students already print out all the apa ni standard code. Mungkin ada juga yang masih belum berbuat apa-apa, so please take actions. Okay, you nak print out for the whole standard, it's very recommended. Okay, it's very good because you will use it again for the next semester, and also apa ni, bila you kerja nanti. Okay, sama je standard yang you akan refer. Okay, so this is the Eurocode, which is actions on structures, okay, or loading on structure. So inside of it is all the information tables regarding to densities, self weight, imposed load, which is another term for variables load. Okay, kalau jumpa imposed load jangan terperanjat, tu samalah juga dengan QK, variables loads. Okay, for the building. So rajin-rajin buka Eurocode here, lihat dalam dia apa ada kan. Kalau you lihat, the first thing is dia dah mula kepada design situations here. Okay, density, the materials with different material, different density, safe weight. Okay, apa ni, all the materials that used for construction depends on the drawing of the architects. And then imposed load here. Okay, mana tables? Dah pergi kepada tables ni. If you look at here, there's a lot of category here. Category A, it mention areas for domestic and residential activities, just for a common building. Examples, rooms in residential building, house, bedrooms and wards in hospital, bedrooms in hotel, hostel kitchens and toilet. Okay, so office area, you have to refer in category B. Okay, so for the C, there's many types of C, C1 ke C2 ke. Okay, then there will be another table here from category A. Is it floors? Okay, which is floor is 1.5 to 2. That means you have to decide what's the QK that you want to use. Kalau malam-malam nak fikir kan, nak rasa selamat, betul kan? Ambil je lah 2, ambil je lah yang maksimum, right? Okay, so staircase, balcony, right? So all the categories here, which is you can refer in this EC1. Tak cukup lagi, they provide you the attachment, another annex here, which is included another tables, okay, for more details, various types of materials, okay, which is if you look at for EC1, it have a partner with the UK National Annex to Eurocode 1. If you refer in the EC2, they also have a UK National Annex to EC2. That means it's a pair here. Okay, there will be additional tables in the UK Nationals Annex which you also need to refer. Okay. So all of these tables here, right, is more detailed areas with tables, public reading rooms, classroom, which is you have to decide, which is you have to observe checks in the drawing and everything. So what the types of, what's the functions of that area. Okay, if A1, A2, it's more details in the UK Nationals Annex. Okay, I go back to our slide. All right, this is how to calculate the safe weight. Okay, we have two types of beam here. Okay, we have two type of beam here. First, we have a rectangles beam. Okay, and then we have a flange beams. So we have a flange beam. How the beams considered as a rectangle beams once the beam is not constructed together with the slab. Once the beam is not concrete or cast together with the slab. So that means this beam is just carry its own load, not carry any load from the slab. Okay. So saya dah bagi contoh kan, this is like a beam here, and then this is the slab thickness, which might be the slab is a type of non-suspended slab, which is is supported by the grounds, by the soil. Okay, so that is what it mean. That is why some of the beams we just design as a rectangles beam here. So in the rectangle beams, we have to consider the size of its cross sections, right? Because we consider the safe weight of the beam as a kilonewton per meter. So it doesn't matter how long the beam, what's the length of beams. So we just consider it B with the width and then dia punya height here. So the cross section size here B multiple with the height, you have to multiply with the unit of concrete. Remember for the concrete is a 20, 25. Okay. Tak semua saya guna pen ni. Okay, then for the flange beam, once the beams cast together, carry the load from the slabs. Okay, so that means the slab will distribute its load to the beam, so it becomes flange beam when we cast it together. So for flange beams, it can be T sections and also it can be L section, depends where's the locations of that beam. Is it beam is in the at the intermediate area or at the corner? Okay, if I draw the layout here of the beams, okay, katalah begini. Okay, so this is the grid lines A, might be this is B, this is C, right? Okay, so this is beam A, this is a beam B, this is a beam C. If I make a cross sections here, so this will be the beams, right? Okay, this is the slab, this is another beams, this is the slab, this is another beam. So that's why there will be a L shapes for the corner beams and T section for the intermediates. Untuk mana-mana beam yang kat tengah ni, it becomes a T sections here. Okay. There will be a effective width for the flange here. So the top one here, okay, we call it as a flange. Okay, please take note on the top of it, which is the area, actually the combinations of slab and also beam. Beam actually sampai atas ni, kan? Yeah, because the reinforcement is cast together here. This is the reinforcement for the beams. Oh, dah terlebih pula So this is the link here. Susah lah kan. Buruk pula tu reinforcement ni, kan. So this is on top of it, we call it as a flange. Yang kat bawah ni we call it as a web here. Okay, as a web. There will be a effective flange width. Okay, we call it as an effective width of flange here. And then also this is the width of the web, which is the size of the beams here. Okay, so what's the effective of the beam here? You will learn it. Might be in this chapter or next chapter, I tak ingat. Okay, while this is the thickness of the slab here, HF. Okay, the thickness of the slab. Okay, some of the slab is not to be as any flange in the beam here. Okay, sebab let's say for these T sections here. Okay, let's say for these T sections. Okay, let's say for this T sections. Okay, so just a portions of the slab here. Okay, just a portions of the slab here. Okay, will transfer the load to this area. Okay, will be considered as a B effective. Okay, it's considered as a B effective. Same goes for the corner here. Same goes for the corner, which is a part of it. There's a portion of it. It considered as a B effective. Okay, so that's why this corner have its own B effective here. Okay, all right. So to calculate the safe weight of the flange beam, we just consider below of the slabs here, the height below of this slab. So that's why H, the total height of the beams minus the thickness of the slab here. Okay, so this is how we calculate, which is the punya weights, and then multiply with the height minus with the thickness of the slab, and then multiply with the unit weight of concrete. Okay, for this beam we consider the whole cross sections. Okay, because it not have any combinations with the slab. This we just consider this height h minus thickness of slab, because at the first process actually we already calculate the safe weight of the slabs, right? We already calculate the safe weight of the slab. How to calculate the safe weight? The safe weight of the slab is by multiply the thickness. Nak tulis H sebenarnya. The thickness of slab multiply with 25, right? So for flange, so that's why we have to minus the thickness, because it's already calculated in the safe weight of the slab. Kita tak nak redundant. We don't want to overestimate. So that's why for the flange, we consider this height here, okay, minus the thickness. Can you understand me? Any questions so far? Sonia, any questions? Oh, Sonia sepi lah. Tak ada
No,
orang
doktor.
kah? Tak ada orang kah? Okay, so this is how we calculate for the safe weight of the column, which is we consider all the dia punya cross sections, and also its length here, its height here, because for the columns, okay. Okay, for the columns we want make it as a point loads, right? Okay, we want to make it as a point load. So that's why B multiple with the H multiple with the L. Okay, you have to multiply with the unit weight of concrete. If that column made of concrete, kalau timber, kalau steel, you have to multiply with the unit weight of that materials. Okay, same goes for the foundations here. So we calculate for its volumes. Okay, B, L's, and also its thickness, okay, with the unit weight of concrete. Okay, for the brick wall load here, okay, look at here, it consider about its height. So that's why we want to know what's the height of each of the levels. Okay, what's the height of each of the level, because we want to calculate the brick wall load here. Okay, so the load of the unit weight of the for the bricks is a 2.6. Okay, 2.6. All right, so this is figures to ensure that you understand how the load transfer. Remember, the load transfer from the top to the bottom, from the slabs to the beams, okay, to the columns, and also to the last one, to the foundations. Okay, let's say this is a type of one-way directions, right, which is a one-way slabs, which is half of the load will transfer to these beams. Okay, will transfer to these beams, and another half will transfer to this to this beam here. Okay, so the load is transferred per area. Okay, we will transfer per area for the slab here, and then this is the brick wall here. Ni brick wall ni kan, this all of this brick wall, which is a uniform slope along this beam here. Okay, the beam also have its own self weight. Same goes for the slabs and columns here. We transfer the load to the columns, and then columns we transfer the load to the foundations. Okay. Okay, the load that apply on a beam may consist of beam safe weight. Okay, may consist of the beam safe weight, and then any permanent loads or variable load, which is from slabs or might be from the secondary columns or other structure or non-structures. Okay, which all of it will be supported by the beams here. Okay, there are two types of slabs, right? There are one-way slab and two-way slab. Ni X, This is X here. Okay, once Ly, once Ly divided by Lx more than 2, it's categorized as a one-way slab. Okay, if Ly divided by Lx is equals, or it less or equal of 2, is a two-way slab here. This is how we make a distribution or sketch, okay, how the load transfers, which beam will carry that loads, will carry that one-way slab or two-way slab here. Okay, so this mapping also you will do in your structural layout. Okay, your first assignment. So each of the panels, okay, you can make this mapping. Okay, these directions for the load distributions. Okay, let's look at how the load transfer one by one here. Okay, for the one-way slabs. Okay, for the one-way slab, how you make it? Is it in these directions, or might be it transferred in these directions? It depends actually the how occupied the beams. Okay, where's the side of that beam, and also where's the long side or long spans of the slabs. Okay, for example, this is Ly here. Okay, which is the longest spans. Okay, this is Lx, the shortest span. Okay, in this case, might be all of the corners have a beam, or might be there's only two sides here, the longest sides that have a beam. Okay, there's no beam at this short side. Okay, so to know the direction is, you have to sketch that we call it as a cracks line analysis. Okay, so the cracks lines analysis is parallel with the longest span. This is the longest span, so this is the cracks line here. So you can imagine kan, one slabs. Okay, once we applied the load, there will be a cracks along the long span. Okay, so this is how we do the sketching, but must ensure that there's a beam here. There's a beam at this side, because the load of the slab will transfer to the beam. Kalau you buat cracks line pun tak ada beam kat sini, tak gunalah you buat loadings transfer, right? So make sure there's a beam also at this side. Okay, so that's why you can that is how you can transmit the load at these directions. Okay, so let's say this is a ly here, this is lx, the short span here. So make a cracks lines along the ly, okay, parallel to the ly. So this is where's the directions of of the slabs here, directions of distributions of the slab here. Okay, let's say another examples. Okay, katalah this is the another one-way slabs. Okay, this is the one-way slabs. Okay, the longest one. This is the longest span is a ly. Okay, the shortest span is a lx. But in this slab, in this case, there's only have a beam at this side. Okay, there's no beam at this side. Kalau tengok method cracks analysis tadi, you akan buat cracks lines along the ly, right? So the load will transfers at this direction, but there's no beam in this case here. So that's why some of the cases you have to look at also the locations of the beam. So in this case, tak bolehlah transfer in this direction. So you have to make the directions, okay, according to the beam's locations. Okay, according to the beam's locations. Okay, because the reinforcements, okay, the reinforcements will be arranged from the beams to the beams. Okay, the main bar will arrange from the beam to the beams. Okay, so if you can imagine, that's why we arrange these kinds of directions, okay, because of also of the bending here. Okay, so if you can imagine how we put the reinforcement in this direction, there will be a large bending moment. Okay, so that's why we arrange the reinforcement along the shortest span. Okay, you can try in your structure drawing kan. So you dah buat positions of the beams, of the columns. You will have a boundary for each of the slabs there. Okay, so you can calculate ly divided by lx. Is it one-way slab or two-way slab? If one-way slab, so you have to sketch how the load transferred. Okay, how the load transferred based on where's the cracks lines should be. Okay, in this case, so this is ly, so make a cracks line here. So half of the load will transfer to this beam, half of the load will transfer to this beam. But at the same time, make sure there's a beam at this side and also there's a beam at this side. Okay. Alright, for two-way slabs, once the ly divided by lx less or equals of 2 here. So still we have a longer span ly, we have a short span lx. How to draw, how to do a mapping for each distributions? It's still the same. You have to draw a line according to the longer spans. Make one line here, okay, parallel to the ly, and then after that you can continue to make triangles, to make a triangle on both sides. So it becomes a triangle and it becomes a trapezium. Okay, another directions might be, okay, this is a ly, this is lx. So you calculate dapat berapa? Mungkin dapat 1.7. So that means this slab is a two-way slab. How to draw the cracks analysis, how to do the mappings. So this is ly, so make one line along the ly. Okay, then you can make proceed with the triangle, proceed to another triangles, and there will be a trapezium also. Okay, it's a mirror. Okay, so this is how the load transfers. So that means this trapezium area will transfer to this beam, there's a portions of it. Kalau one way is just half, right? 0.5, 0.5 is quite easy. But for the two-way, there will be a table coefficients to know what the portion, the portion for this trapezium's area will transfer to this beam, and also what's the portions, what's the coefficients area for this triangle that will transfer the load to this beam and transfer the load to this beam. Okay, so this is very, very important. Sebab this is the first process, because the load will first transfer from the slabs, right? And then baru you boleh design, baru you boleh calculate the loads of the beams. Okay, once I put a star here, that means this is it's very important for you to understand. Okay, in the design process. Okay, look at of this layout here. Okay, so all of the slabs here, you can see here, have its own boundary, have its own space, right? So it doesn't matter what's the functions for each of the panels, because we want to do some exercise on how to do a mapping, on how to distribute the load of the slab. Okay, so please help me to determine for the panels A, Ly divide by Lx. Dia punya Ly, the longest span is the 3825 here. Divide by the short span is the 3625. So what's the value? What's the ratio? Tolong kira. Give me the ratio. 1.05, so you can say as a 1.1. So that means this is the types of one way or two way.
Two-way.
Two-way, okay, two-way. How to do the mapping? Look at which one the longest span. Ni 3825, which is Ly. So make one line parallel to the Ly. So then continue to make a triangle, and have a trapezium. So this is how the load transfer. This portion will transfer to this beam, 1, 2, 3. This load will transfer to this beam, 1 from A to C. Sama juga macam side yang lain. Okay, how about this one? Okay, for panel 9 here. Ly dia 3825 divide by Lx 1285. Berapa? Kalau tengok dah tera kan. Ni one way ni. Sebab kita nak belajar, we have to confirm. What's the value? This ratio. Come on.
2.98.
2.98. Okay, so that means this is a one way, confirm one way slab. How to do the analysis? Okay, so this is the longest parts, right? Longest span. So buat satu cracks line here. So this is how the load transfers. Half of it will transfer to this beam, and another half will transfer to this beam. Okay, so same goes for other slabs. You need to do it by yourself. Okay, so kalau void ni, there's no slab here. So that means this beam only carry its own self weight, or might be ada brick ke atas dia. There's no slab. This beam can be designed as a rectangle beam. So nampak tak example the rectangle beam? This beam have to design, if it connected each other, have to design as a T sections here. Okay, if I cut here, it have to be as a flange beam because there's a load, there's a triangle's load that transferred on it. Okay, so tolong buat exercise untuk panel lain. I give you about 10 minutes. So we take a break. At the same time, please do some your own exercise before we can proceed to other slides. Okay, so this is very important for you to understand. This one also you will apply for your structural drawing for assignments. Dalam assignment nanti you kena sketch juga. Okay, for every panel sketch which one is one way, which one is two way, how it distributes. Okay, so take a break for 10 minutes. Okay, so macam mana? Okay tak? Any questions? Any questions so far?
Tak ada doktor.
Okay, saya tak buka kamera semalam kelas pun saya tak boleh nak buka kamera sebab berapa kali saya lost connections ni. Ni baru sekali so you bersabarlah kalau banyak kali saya lost connections ni. Dekat office I tak tahu this week's internet connections are not so good. Okay, this is how to calculate the loads. Okay, kalau lihat one way spanning slab or one way slab here. Okay, katalah this is a kind of one examples of one way slabs. Okay, so this is the cracks lines. Okay, according to the LY, parallel to the LY, this is how the load transfer. This half of the load will transfer to beam BD. Another half will transfer to beam AC. So which is just directly split into two, which is 0.5 from the load from the LX will transfer to both sides here. So that's why AC and BD is the same loading. Okay, is the same loading, which is W, okay, the load, okay, 0.5 or 1 divided by 2 here, multiple with the N and also multiply with the LX here. So maksudnya all the load here is the N, What is N here? Yang korang kira lah, safe weight slabs, right? Depend on its thickness, and then what else? Finishes, and then plus kalau ada shillings. So total of it is N here, So this load will be applied per area, okay, for this whole area of the slab. And then that's why 0.5 multiply with the load and also half of the LX. Okay, how about for beam AB and beam CD kat sini? There's no load transfer to it, right? There's no load, there's no slabs distribution transferred to this beam AB and CD. So that's why W is 0. Okay, sama juga kalau ada case, okay, kalau dia transfer to this area, transfer to these directions, this is the beams all around of it, so half will be transferred to this beam and another half to this beam. This beam W is 0, this beam W is 0. So that means this beam just carried its own beam. There's no slabs load should be considered. Okay, so this is for two-way slab. It's more complicated here. Okay, compared to this one way. One way just directly divide by 2. Kalau two-way, it have a portion for triangles and also portion for trapeziums. Okay, so for beam AC and beam BD, will cater a load from this area, from this trapeziums area. Okay, kalau beam AB and beam CD will collect the loads, will carry the load from this triangle here. Okay, so this is the equations that can be used, okay, to know what's the portion of it, okay, which is all of these equations multiplies the same basics, multiply with the N, okay, which is the load here that apa ni, applied per area of the slab. Okay, and then also the LX here. Okay, portions from the load and portions from the LX here. Okay, kalau AB and CD is about 1/3. Okay, 1 divided by 3. Okay, quarter from the N from the LX. So actually it's basically it's come from the area. It's come from the area. Okay, so this is methods if you using the equation. Okay, but EC Eurocode come up with a simplified method, which is you just refer in the table for its coefficients. Okay, just refer the coefficients and then just multiply with the N and multiply with the LX. So what the table is in BS 8110 here. Okay, tables 3.15. So I put a star here. You need to know where's the table. You need to open British Standard 8110. Okay, so in the table it give coefficients. Okay, for coefficient for span LY. That means for the beam AC and beam BD. Okay, sama juga beam BD, and give a coefficient which label as a beta Vy for short span. Okay, for beam AB and beam CD. So that's mean for these portions is coefficient for beta Vx. This one also same, beta Vx. Kalau this triangles is beta Vy, beta Vy. This coefficient have to refer in the tables 3.15 BS8110 here. So that means beta Vx here, this is coefficient for trapezium. Please take note kadang confuse kan, beta Vx ke beta Vy ke. To ensure not confused, do some note, do some sketching. Okay, tangan kena gerak. Okay, jangan duduk tengok je. Please do some things to ensure that's what I've teach terus absorb dalam apa ni, dalam kepala tu. Okay, so BVY for triangles. Okay, so this is the tables that I mean. Okay, so these tables have all the cases here. Okay, so if I show you in the BS, okay, so ni lah BS nya. Okay, dah tengok ke belum ke dalam otak? That is apa ni, your decisions. Okay, that is your decision. Either you want to work smart or not, what last minute ke, so depends on you. Dah besar semua kan. Okay, so British Standard 8110. So this is for the part 1 code of practice. That tables can be found at page 43. Kalau you dah selalu tengok, dah selalu refer tables, lama-lama buka je dah tahu dah page dekat mana kan. Okay, so this is a table for this is table in page 43 in BS 8110. Okay, so this table is a very important. So look at here, there's a beta Vx. Remember, beta Vx is a coefficient for trapeziums. Beta Vy is a coefficient for triangles. Okay, so buat gambar kat sini dekat you punya tables tu, dekat you punya BS. Make it larger. Okay, kalau saya punya BS, saya memang ada lukis. Saya tak nak confuse. Okay, so nanti BBY pun saya lukis. Okay. Alright, so the first column here, it give apa ni? Different types of panels and its locations. There are many cases here. You need to understand each of the cases. What's the types of the slab panel that you want to design. So examples number 1 here. It mentioned here 4 edges continuous. Okay, 4 edges continuous. That means if you draw the panels, let's say this is the panels, all the panels, all the side continuous with the beams. Okay, continuous with the beam. Remember, this is for two-way slabs. Okay, this is for this table for two-way slab. Kalau one-way slab, tak payah tengok table. Just divide by 2. It's loads and also it lengths, right? But for two-way, it's more complicated here. So that's why EC2, EC1 come out, BS come out with this tables here to simplify the equations. Okay, so you need to understand each of the cases. 4 edges continuous. So you need to do some drawing here. Dulu saya study pun saya lukis. Setiap petak ni saya lukis. Apa yang dimaksudkan 4 edges continuous? Okay, this is example of 4 edges continuous. This is example of case 1, which is all around of it continuous to other structure. Okay, all side, all corner continuous to other beams. Okay, so another example lah. Ni pun sama juga. This is can be also case 1. So ada lagi tak? So this is the void. Be careful. Okay. Alright. So then you have to look at here. Okay, for coefficient of BVX. That means for this value is 1, 1.1 up to 2 here. Because of two-way, right? Two-way is Ly divided by Lx equal or less than 2. So that's why the last column give a value of 2. So kalau lebih daripada 2, it becomes one way. Tak boleh tengok tables ni. Okay, so that's why the value just up to 2 here. So you need to calculate Ly divided by Lx. Let's say 1.1 dapat. So 1.1, that means you punya BVX is 0.36. Okay, so for the triangles is 0.33 here. Okay, case number 2 here. Okay, for the case number 2. Sorry, for the continuous edge here. Okay, for the continuous edge here. Okay, let's say for the case 1, we still stick in the case 1 here. Okay, this is Ly, this is Lx. So you make one line, right, parallel to the longer span. Make a triangles. Okay, remember, for this trapezium is a BVX. Let's say Ly divided by Lx is 1.1. So that means the continuous edge is 0.36. So this is continuous, right? This is continuous. So that's why there's a continuous and there's also coefficient for discontinuous edge. Mana side yang continuous, ambil this value. Mana yang discontinuous, might be there's a sum of it have a value. Depends actually on the locations of the panels. So for this example, let's say 0.36 for BVX. For trapeziums coefficients. For triangle is 0.33. So 0.33. Okay, sama juga kalau this is one also for the case 1. 0.33. This is same 0.36, 0.36. Okay, Then look at for the case 2 here. Word panels. Okay. One short edge discontinuous. One short edge discontinuous. That means the rest continuous. Satu short je discontinuous. Buatlah simbol apa? Katalah buat cross. One short discontinuous. Yang lain continuous. Tengok kat sini contoh case yang mana. Okay, this case, right? Case 2, which is this side, this beam not continuous to other structure, not continuous to other slabs. Okay, this one continuous to other structure, this one continuous to other structure, this one continuous to other structure. Okay, so make a line. Let's say this is the line for two-way slab. Okay, tak lagi Okay, look at for continuous and discontinuous here. Katalah you calculate this one, Ly divide by Lx, Ly divide by Lx, dapatlah 1.23. Okay, refer these tables. Okay, case 2, dia punya Ly divide by Lx is the 1.23. So there's no 1.23 here, but this is the nearest one. Kalau dah lebih 1.26 more than 5, right? 1.26, 1.27. So this will be the nearest one. Okay, so nama pun estimates, right? Okay, so let's say 1.2 here. Okay, refer, this is the continuous value. Okay, the coefficient for the continuous part 0.42 for this trapezium. These two trapeziums, right? Both of it continuous. So 0.42. Yeah, 0.42. 0.42. Nampak ni discontinuous edge. Tak ada pun trapezium yang discontinuous, right? Dua-dua continuous. So that's why there's no value for discontinuous edge here. Okay, for triangles, pergi dekat last column. So there's two conditions here. Continuous 0.36, discontinuous 0.24. Lihat sini, this triangle is discontinuous, right? Which is the value is 0.24. This is a triangle which is continuous edge. So 0.36. Can you understand me? Masa nak masuk je dalam laptop ni kan, nak bagi faham. Can you understand? Ada faham?
Faham.
Okay. So sama saja untuk yang lain. Ni kena buat practice juga. Ni pun kena buat exercise juga. Buat semua sketch ni. Draw for each of the conditions here. Okay. Jam pula ni. Okay, contoh case 3, buat dulu panels. It mentioned here, one long discontinuous. Satu je yang long side discontinuous. Satu long side. Yang lain semua continuous. So buat lagi draw nak bagi faham. It mentioned here two adjacent edges. Adjacent, that means one short, one long discontinuous. One short, one long discontinuous. Yang lain semua continuous. This one, two short discontinuous. Dua short discontinuous. Sorry, cross. Okay, ni continuous, discontinuous. Two long discontinuous. Two long discontinuous. Buatlah yang lain pilih adjacent, maksudnya satu pendek, satu panjang, discontinuous. Okay. So kalau macam ni, 3 edges kan, 3 edges discontinuous, dalam brackets 1 long edge discontinuous. That means one of it is a long edge that is continuous. So it should be one long discontinuous and the rest is for this short only one long discontinuous. So this is continuous. Okay, you can try other cases also. Okay. Okay, so this is one of the examples on how to calculate the load from the slabs. Okay, determine the characteristic permanent. Tengok, baca je dah faham kan characteristic permanent. Which is you have to determine the GK. Okay, you have to determine the GK and variables actions. So you also need to calculate the QK on beam FB1. Which one beam FB1? This is the FB1. This one also FB1. If you look at here, it's only two sides that have a beam. So supposedly the directions, the reinforcement should be from beams to beams. Okay, from beams to beam for the reinforcements arrangement. Okay, it give a data for the brick wall here with 4 meter height. So tinggi brick ni adalah 4 meter. Is sitting on the beam. That means this brick will be applied its load to the beam. This beam will carry the load from of the brick wall. Unit weight of concrete 25. Ni standards. Finishes 1. So nampak finishes tak payah nak kira lagi kan, tak payah nak buka tables, is already given here. Okay, for the finishes. Remember, finishes is a part of GK, right? Okay, brick wall is also load for GK here. This is the unit weight 2.6 and variable actions. Variable action pun dah bagi. Tak payahlah nak tanya-tanya, nak angkat tangan. Ni sekolah ke? Ni rumah ke? Ni koridor ke? So dia dah bagi QK here. Okay, which is 4.0. Okay, so this is how the load will transfer, which is this beam will carry the load from the slab, okay, according to its distributions, one way or two way. Not all the load will transfer to this beam. It should be distributed, right? Because we have other beam here. And then also the bricks also will transfer its load to this beam. This beam itself have its own self weight. Okay, so that's why you need to understand each of structures, the loads that should be considered. So this will be the distributions along the beam here. This beam length is 8 meter, which is all the load we transferred per meter along the beam, which is have a GK, safe weight, brick wall, slab, and then QK, which is slab here. Okay, so this is how to calculate for the safe weight of beam by consider it cross sections of the beam. So that's why you had to know what the size of the beam. Okay, and then multiply with the unit weight of the concrete. Okay, unit weight of the concrete, which is the safe weight here is a 4.38. Then have to carry the brick wall, right? Have to carry the brick wall. The brick wall unit weight is a 2.6. This one is standard. Same goes for the concrete. Standard one is a 25. Okay, and then this is the height. That's why you have to know what the height of that levels. Okay, 10.4 here for the brick. Then for the slabs, okay, for the slabs, dah kira beams, dah kira wall, then you have to calculate for the slab here. Okay, for the slab you have to consider its thickness. Berapa thickness for this concrete? Okay, which is 0.15 here. Dalam data dia bagi tak. It mentioned here, it mentioned in the drawing, 150 mm thickness precast slab. Okay, thickness dia make it convert into meter. That is a precast slab which is made of concrete. So 25, okay, dia punya unit weight. And then we also have to consider finishes, right? Okay, plus dengan finishes. This is the total one, which is 4.75 will be applied for this whole area. Okay, so this is 4.75 will be applied onto this slab. Okay, so that's why half of it will transfer to FB1, another half will transfer to other side. Okay, separuh lah sebab sini ada beam, sini ada beam. So terpaksa lah bagi sana separuh, bagi sini separuh. Okay, walaupun kalau you calculate dia becomes one way ke two way ke in other direction, but as long as it only have two beams here, it have to transfer half to this part, another half to this part. Okay, so half of the distribution to FB1 is 14.25. You need to total all the weight here from the beams, from the brick walls, from the slab distributions, okay, which is 29. Okay, so that's mean GK is 29. QK also you have to divide by 2. Okay, dia punya distribution 0.5. Okay, apa ni, dia punya QK dia adalah 4 and then this is the LX. Okay. Then this is the other example. It gives a more proper drawing. So these examples is quite similar. Okay, for your tests, for your exams, this is how we will give the data, and also we will give a part of the drawing. Okay, it mentions here, okay, you need to determine the permanence and also variables loads for beam B123. So mana beam B123? This is the beam B grid lines, okay, from 1 to 3. So that's why grid line is very important. Okay, so this is the beam that you will design. Don't look at other beams, just focus for these beams here. Okay, givens, unit weight concrete 25, finishes, shielding and services. It already given here 2.0. Okay, dia punya finishes semua. Variable actions, which is its QK is a 3 here, right? So in order to know what's the loads for this beam here, okay, you need to understand that is that a suspended or non-suspended slab. Okay, remember this is the dotted line here. That means this slab, this slab, this slab also is cast together with this beam. The slabs here will transfer the load to this beam. Okay, kalau I buat sketch, if I cut here, okay, you look at from here, mata letak kat sini, tengok dari sini. Okay, so there will be a beam here. And then this is the slabs, right? The slabs, and then this is the beam, this is the slabs, this is the beam. Okay, so this will be the beams that you will design. Okay, this is a T beam, which is a flange beam. Might be the B effective will be around at this length here. Okay, so these T beams will carry the loads of the slabs, right? And also its beam. Okay, it doesn't mention about the brick wall here, so that's mean you don't have to calculate the brick wall. There's no brick wall on top of the beam here. Okay, so nak tahu dia punya distribution, you have to know, is it this slab, or this slab one way or two way slabs, right? You have to distribute the load from the slab. So kalau ni dia punya length dia which is ly, right, which is 7.5, okay, for this beam here. Okay, for this area 7.5 divided by 2.5. Kalau dah terror, dah expert, tengok je dah tahu kan, oh this is one way. Okay, so this one one way or two way here, this will be its distributions here. Okay, ini distributionsnya, you boleh try calculate. Okay, how it distributes. This is 4.5, this is 4, right? So that's why there's a one line here, make the triangles here. So if you look at here, okay, this is how the loads of the slabs transfer. That means half of this panel 1 we transferred to this beam B, and these portions of triangle will transfer to this beam, and these portions of trapezium will transfer to this beam. So that means you can just ignore other portions. Padam, jangan tengok yang lain. Tengok apa load yang transfer pada beam B saja. Just ignore other parts. Okay. So this is the load that you have to total up, that will transfer to this beam here. Okay, so what's the loads? What's the end value here? So tu yang kena kira. Kira lah actions on slab here. The safe weight of the slab based on its thickness. It mentioned here 150 mm, its thickness. So 0.15 multiply with the unit weight of concrete, 3.75, and then have the finishes, shilling and services. It already gave here 2. Okay, and then total up this one. So 5.75 for value for GK, and QK is a 3 here. Okay, this load is all around that applied for the whole area here. Kan? So but we need to distribute because we have a one way distribution, we have also two way here for trapezium, for triangle for trapezium. Okay, so ni you have to calculate lah dekat dalam tables nanti, you need to know, right, this Ly divided by Lx. Okay, so you need to calculate one by one. Okay, kalau one way senanglah 0.5 darab dengan n. N tadi apa ni? Ni lah n. Okay, loading dia 5.75 dengan 3. Okay, so part 1, panel 1, GK or QK that distribute to this beam is 0.5, half from its GK, right, which is 5.75, and then multiply with its LX, 2.5 here. Okay, QK pun sama. Okay, so this beam, this slab have a GK which is 7.19, okay, and then QK 3.75. Okay, that will transfer to this beam. Okay, buat pula yang ni, triangles pula. Apa triangles adalah BVY. A trapezium adalah BVX. Refer the tables. Okay, refer the tables. Okay, so BVY here, okay, you have to refer for the last column. Okay, for triangles coefficients. What type of this one? This one is two adjacent edges discontinuous. Betul ke? Ni short, discontinuous. This long, not continuous. Tu yang you refer case, you refer drawing yang you buat tadi ni kan. Ni refer. Mana yang sama dengan dia punya locations. Okay, which is so in this case is a two-way adjacent edges discontinuous. One short, one long, discontinuous. Okay, BVY. You need to know what is apa ni LY, LX ni ke? Apa ni LY, LY, LX perlu tahu ke? Tak perlu sebab this is a BVY, right? Which is you just need terus ambil the last column. Just to know, is it continuous triangle or discontinuous? Remember, we also have another triangles, right? But this one discontinuous. But at the same time, we also need to ignore this side because we focus for this beam. So that's why this triangle is a continuous edge. So ambil yang continuous edge 0.4. So that's why mean this is a BVY for panels 2. Okay, 0.4 dia punya coefficients darab dengan GK and then multiply with it short length LX. So untuk W3 pun the same the same case here, which is one long, one short, discontinuous. The rest continuous. So sama juga kena refer kat sini. But this is trapezium. So trapezium need to know what's the value for LY divided by LX here. Okay, tengok tadi dia calculate berapa. FS3 1.13. 1.13, which is this is the nearest one. This trapezium is the continuous edge or discontinuous? This is continuous, right? Continuous one, right? Okay, so that's why you need to use 0.44. Jangan ambil discontinuous yang another part ni, which is the part that we not consider. Okay, so this is the continuous trapezium 0.44. Okay, so dapat semua kat sini. You can list out. Okay, which is this is dia punya GK 6.9, 6.9, and then QK is 3.6. Sini pun sama, dia punya GK dia 10.12. This is a QK is 5.28. Okay, consider from span 1 to 2 to 3. Okay, according to its grid line here. For beam 1 to 2, the load that transferred to this beam is this area and this area. So that's why 7.19 will plus with 6.9. This is the GK for grid line 1 to 2. Same goes for QK. Only this part will transfer to this beam. Okay, so 3.75 plus 3.6. This is the QK for this grid line beam 1 to 2. Kalau grid line 2 to 3 pula, this is the value that we transfer to this beam. So that's why there will be a differences of this span. Okay, you kena lihat span 1 to 2 apa load yang transfer kat dia. For span 2 to 3 apa load yang transfer dekat dia. Okay, so this is how we do the load estimations. If you do mistakes here, there will be another mistake till the end. Okay, sampailah you pilih size, reinforcements, berapa size, semuanya salah sebab you salah kira load. That's why load estimation is a very important. Salah kira load apa ni uh, um, uh, tends to collapse the buildings, okay, because of the wrong estimations of the load. Okay, faham tak?
Faham, Doktor.
Okay. Then we also have a secondary beam. Okay, remember we have a secondary beams here. Okay, let's say ada secondary beam kat sini. Okay, let's say ada another beam here. The secondary beams, that means the beam is supported by columns. So that means there will be a point load at this beam here. So that is mean by the secondary beam. So if have a secondary beam, it's still the same. You have to calculate the secondary beam first, then barulah you transfer the support reaction from secondary beam to the main beam. Okay, contoh macam ini. Ini bukan assignments lah. This is your own exercise. Okay, ni you punya own exercise. Balik ni, balik pula apa kan? Memang korang kat OSEC kat rumah kan? Kalau pergi kelas bolehlah cakap balik nanti. Okay, nanti habis kelas, apa ni, please do this your own exercise. Okay, so in this case, let's say the same apa ni, the same drawing tadi, cuma dia mention kat sini column 2B have been removed. That means there's no support here, there's no column here, so dia jadi beam saja kat sini. Semua ni, which is that means this beam is supported by beam B. So if I do the sketch, okay, for the secondary beams, you need to calculate for secondary beam first. This is a secondary beam support by beam B. Okay, kat sini beam B. Another side is support by column. Grid line dia berapa? Column 2. So nampak tak? So how about its loads? What is GK? What is QK? Sama je kira. Sama je. You have to focus on this beam first. What is GK? What is QK? What's the load transferred to this beam? Kalau macam ini, you nak focus for this apa ni? Secondary beam first. Okay, so that means you have to focus this area and also this area. Okay. Ni je lah apa ni load that transferred to this secondary beams. Dapat GK, dapat QK, right? So beam BB will have a reactions, right? So from this loading, you can calculate what's the RY, what's the RY for this one. This RY will be pointed at this beam B. Okay, cuba buat pula beam B. Sini tak muat, sini. Okay, this is the main beam. Okay, beam B from grid line 1 to 3. This is the sketch of the support system, which is this is grid line 1 here. Okay, and then another support, only 2 supports, right? Because we already removed the columns at the middle. So at grid lines 3, this is the support. Then we have a point load from the secondary beam. RY kat sini at the grid line 2. This is RY. Okay, at the grid line 2. Same goes for the loadings. You have to focus for this for these beams, the loads that apply on it. Okay, jangan tengok yang lain, just focus on that beams. But the different thing is it only have a point load here. The rest is still the same. The rest of GK, QK is still the same. Only have to know what's the RY that pointed here. Okay, you can do your own exercise. Okay, so that's it. That's it for today. Okay, I stop here. Next week we will start from this slide. Okay, so any questions? I will turn on the attendance. Okay, you can submit your attendance, but before I stop the class, ada soalan? Kadang buat exercise barulah nampak nak tanya apa kan, barulah faham apa yang tak faham. Okay, so senyap je kan, so I think you semua faham ataupun you nak buat exercise dulu ke? Ada soalan ke? Siapa tadi? Mastura.
Doktor, boleh tak nanti tolong bagi jawapan untuk exercise ni?
Tak ada jawapan.
Maksudnya, tak ada jawapan
Tak ada jawapan. You all kena cari jawapan. Okay?
Okay, doktor.
Alright. Okay. So, any questions? Yang lain-lain? Hisham, Aimi, Najila, Auni. Everything's good?
Okay, doktor.
Alright.
Doktor,
Yeah.
nak tanya kalau dia punya slab dia bukan segi empat, dia L shape, dia macam mana kira?
Make it simple. Make it as easy as you can design it. Kalau dia L shape, cuba jadikan dia rectangle. Sebab kalau macam tu susah nanti you nak design.
Okay, baik doktor.
Okay, so that's why we add additional beams, right? We add additional grid lines. Okay, so kalau kita kena buat boundary, make it panel by panel. Mungkin ada slab tu dia dapat layu 4 segi kan, tapi mungkin ada sikit macam gitu kan. Mungkin ada sikit macam ini. So you as a designer, normal estimation, so might be in a design, in the loading, you can assume as one area here, as one per meter here, kan ada secong add sikit ni kan. So you punya decisions, as long as is not underestimate, tapi jangan overestimate pula. So just nice. Okay. Alright. So I think that's it for today. Okay. So I stop the class right now. We'll see you again next week. Okay. Thank you everyone. Don't forget to